Hello everyone and welcome to our expert sessions. Thank you for joining us today. These short webinars take place every week and run for about 30 minutes, offering valuable insights from the industry experts on key electrical safety and grounded topics. Today's session will be presented by Devansh Thakkar, our product marketing engineer here at i-Gard. Devansh is an electrical engineer from Charusat University in India. With experience in protection systems and relays, over the past 2 years, he has worked closely with customers, providing technical support and troubleshooting across a range of products and applications. He specializes in solutions for high and low resistance grounded systems, hybrid HRG systems, drum-fault and arc flash protection, as well as resistor-based and personal protection products. We're very glad to have him with us today, and thank you all for being here. And with that, I will hand it over to Devansh to begin the session.
Thank you, Andrea, and welcome everyone. Today's presentation is about voltage indicators in the absence of voltage tester and things to know about it. Over the years, safety standards have evolved. We are highlighting some changes in NFPA that took place in 2015, 2018, 2021, and 2024 regarding the verification of an electrically safe work conditions and how each revision mandates the use of various voltage testing devices. In 2015, the only option to verify an electrically safe working condition was to use a multimeter to test the phase conductors or circuit paths directly. This requires opening the door to an electrical cabinet with appropriate safety equipment and making direct contact. In 2018, Clause 120.5 was introduced, and with the exception 1 to Rule 7, permitting the utilization of voltage test ports for performing the absence of voltage test. In 2021, Clause 120.5 was revised and exception 1 was updated to include a permanently mounted listed absence of voltage tester. The 2024 revision enhanced the clarity of Rule 7 by specifying that tests must be conducted at the actual point of work. There are 3 types of voltage testing devices. First one, voltage indicator. It will show if the voltage is present but cannot confirm if it is completely gone. Second is voltage indicator and tester. Adds the ability to measure voltage but still only check for presence of voltage but not the absence confirmation. Absence of voltage tester, the safest option. It not only indicates the voltage but also automatically verifies the circuit is truly de-energized before the work begins by just pressing the test button on the module. We'll discuss about this feature in the coming slides. AVTs eliminate the guesswork and provides the highest level of safety compared to simple indicators or testers and confirms the absence of voltage. Voltage indicators are useful for showing if electricity is present, but they have some limitations and safety concerns. They cannot confirm the voltage is completely absent, which is critical for safe work. Sometimes the light may give a false reading due to issues like faulty LEDs, incorrect installation, or device failure. These indicators also require a separate handheld tester to measure voltage and verify the power is off. Additionally, because they bring the line voltage to the panel door, they can pose a shock hazard, especially when troubleshooting with the open door. The voltage presence indicator and tester is a safety tool that helps you quickly check if electricity is present in a system without direct contact with live wires. It uses bright LED lights to show whether voltage exists in each wire and ground, and it works for both AC and DC power. The device also includes special protected test points that allow safe voltage measurements through the panel door, reducing the risk of electrical shock or arc flash. This makes troubleshooting easier for issues like missing power, low voltages, phase failure, or incorrect phase rotation while following NFPA 70E safety standard. NFPA 70E revision of 2024 Annex O.2.4 included the installation of absence of voltage test port under the section heading Additional Safety by Design method and recommends voltage measurement through the door using the test port. This method has proven to be effective in reducing the risk associated with arc flash or electrical shock hazards. Now let's talk about absence of voltage tester. It is used to verify the absence of voltage in electrical circuits and to see if the equipment is de-energized and free from hazardous voltage before maintenance or repair begins, reducing the risk of electrical accidents. Using AVT is simple. A person can press a button to test button to initiate the test sequence. AVTs automatically self-test using a known voltage source and checking for the direct contact with the circuit during testing of for both AC and DC voltages, including phase to ground and phase to phase. If the test is successful and there is less than 3 volts AC or DC in the circuits, 3 green lights will glow for 5 seconds. This indicates the situation is safe and the electrical panel door can be opened. In case of an unsuccessful test, either 3 red LEDs will glow, confirming the presence of voltage, or the amber lights stay illuminated, indicating potential unsafe condition. The absence of voltage tester follows a rigorous automated process to ensure true de-energization before work begins. It starts by verifying sensors and phase connections, then checks that energy levels are safe for testing. The AVT performs multiple tests for AC and DC voltages across all phase to phase and phase to ground points, along with the connectivity checks to confirm proper wiring. A built-in supervisory circuit validates the tester functionality before and after the test. When all check passes, steady green LEDs indicate it is safe to open the panel, eliminating the guesswork and reducing the risk. If any of this step fails, the AVT will show amber lights indicating the potential unsafe situation. CSA Z462, the revision of 2024, and NFPA 70E 2024 now allows permanently mounted absence of voltage tester to confirm the equipment is de-energized, provided they meet strict requirements. AVTs must test at the point of work, be listed for absence of voltage testing, check all the phases, and verify their own operation before and after testing. This makes AVTs a faster, safer, and fully compliant alternative to handheld testers. Not all devices meet NFPA 70E and CSA Z462 standards for verifying absence of voltage. To comply, the tester must be permanently mounted, test conductors at the actual point of work, and be listed for this purpose. It should check all phase-to-phase and phase-to-ground connections and verify its own operation using a known voltage source before and after testing. Finally, it meets all UL 1436 design requirements. Many indicators and portals fail these criteria. They only show voltage presence and requires handheld tester for confirmation. A true absence of voltage tester meets all the requirements, ensuring compliance and maximum safety. Compliance with UL 1436 ensure maximum electrical safety. An absence of voltage tester is a permanently mounted device that verifies a circuit is truly de-energized before work begins, meeting strict UL 1436 and IEC 61508 standards. It provides a green visual indication only after confirming the absence of voltage, uses a supervisory circuit and secondary power source for reliability, and prevents false signals. With SIL3 safety integrity, AVTs deliver accurate fail-safe verification, far superior to simple indicators, protecting workers from shock and arc flash hazards. Voltage indicators and test portals are often mistaken for the tools that confirm the absence of voltage, but they do not meet the safety requirements for the critical task. Indicators only shows the presence of voltage. If the lights are off, it does not guarantee that the circuit is de-energized. This can lead to dangerous false assumptions. Indicators also lack a supervisory circuit to verify proper operation, meaning they could fail silently due to installation errors or device faults. Additionally, they bring live voltage to the door, creating shock hazards during troubleshooting. On the other hand, an absence of voltage tester, i-AVT, is designed and certified to meet UL 1436 and IEC 61508 standards, including SIL3 safety integrity. AVTs perform an actual test at the point of work and include built-in checks to ensure the tester is functioning correctly before and after the measurements. They also illuminate when the test confirms the absence of voltage, eliminating the guesswork and reducing the risk. Simply put, AVTs provide a reliable, automated, and safer way to verify the equipment is truly de-energized, whereas voltage indicators cannot be trusted for this purpose. The i-AVT Plus is a next-generation safety device that combines the function of an approved absence of voltage tester and the voltage indicator in one unit. It ensures the compliance of UL 1436 and SIL3 standards by providing a reliable way to confirm that equipment is truly de-energized before the work begins. Unlike simple indicators, i-AVT Plus performs an actual absence of voltage test at the point of work and includes a known voltage source for verifying portable testers. It also allows safe troubleshooting through closed doors test points. all housed in one IP67 enclosure for maximum protection. This combination delivers unmatched safety, accuracy, and convenience for electrical maintenance. Now, here's the comparison of the units between the individual absence of voltage tester, individual voltage indicator with test ports, and the simple voltage indicator, and the combinational unit, which indicates that the combined i-AVT plus will have all the features of voltage indication, test ports, and the absence of voltage in one enclosure. Our absence of voltage testers comes in different models to handle a wide range of electrical system. Whether you work with an AC or DC power, we have options for voltage from 600 volts up to 15 kV in AC, and in DC variation we have 250 volts DC up to 3000 volts DC. This slide provides an idea of a typical wiring diagram of a 5 kV absence of voltage tester for the AC system on the left side and a 2.5 kV version of DC system on the right side. So this will give you a little bit idea on how the absence of voltage tester gets connected into the system. Thank you everyone for your time today, and the floor is now open for questions. Would this device be acceptable to use getting its voltage signal from PTs instead of direct from the bus? Unfortunately, we cannot use PTs in this arrangement because UL 1436 does not allow PTs to be utilized. So we have to actually connect directly to the point of work on the bus. And regarding the use and significant equipment, your competition gives fail-safe positives in the presence of electrical noise from the adjacent equipment. Does this have a built-in battery? It uses a supercapacitor technology to provide the energization to the i-AVT when the bus is de-energized to perform the test, and it gives 10 hours of backup, and you can perform 15 test sequence in that time. And if you wish to perform more test sequence and have it last longer, we have a USB-C type charging port where you can connect it and charge the capacitor. When to use the VTI and when to use the AVT if I have a AVT plus. So as I mentioned previously in the slides, VTI is used for voltage indicators and testers. So is only useful when we have to check the presence of voltage in the system while the system is energized. But if we want to use the absence of voltage tester, it can be used only when the system is de-energized to confirm the absence of voltage tester. However, it will also give you indication of the presence of voltage. Why can I not use the test portals as an absence of voltage? Why can I not use the test portal as an absence of voltage? It is permanently mounted. I'm not sure about this, but let me gather more information and I can get back to you for this question. I have a pen tester that I use for testing voltages. It fits in my pocket and I use it everywhere. What is wrong with that? That's a good question. I don't have much insight about this.
Devansh, can I interject?
Yes.
First of all, why can't you use a test portal as an absence of voltage device? Well, it's not UL listed for an absence of voltage device. It is a permanently mounted device, but it's not UL listed as a absence of voltage tester. It is a voltage test portal at best. So it's great if you're using 70B and you need to do some troubleshooting, but it is not an absence of voltage tester. As far as the pen tester, those are excellent tools. Yes, they fit everywhere, but there's limitations on the pen testers because they do not do DC and they have limitations on the bottom threshold. An absence of voltage tester needs to test down to 3 volts AC and 3 volts DC, and the pen tester does not do DC, and it can't, well, most of them, I would say 95% of them do not go down to 3 volts AC. They have a threshold of 90 volts for some of them are higher, but there's a limitation for that. Still a hazardous voltage, not an absence of voltage tester. So they should never be relied upon for the absence of voltage. At best, they can tell you if you have a presence of nominal voltage. And the test portal is not an absence of voltage device. It is a testing aid for troubleshooting. When you have an absence of voltage test device, you have to rely on the security that that unit has been tested, and it's a rigorous test for UL 1436 for an absence of voltage device. So you have to test to make sure that that unit is SIL3 rated or better. That means it will not give you a false indication at any time. Safety intrinsic level 3 is crucial for these devices. It has to actually test itself to make sure that it's functional and working, and a test portal cannot do that. Now, don't get me wrong, test portals have their place. They are excellent troubleshooting tools, but when it comes to life safety, they are not tested rigorously enough as an absence of voltage tester. Those of you that do have pen testers, take a look at the back of it and make sure that it goes down to minimum 50 volts, because OSHA says anything above 50 volts is a hazard. So if it doesn't go down to 50 volts AC and DC, and I know they don't do DC because it's a capacitive charging system, so they can't be used as an absence of voltage tester. Thank you.
Do we have any further questions? So having a comparison of the way we do it today, how you would do this tomorrow, is it really required or just helpful? I did not understand the questions.
May I?
Yes.
So I guess the question is, if this is a requirement to be used in testing for the absence of voltage. It is, and you don't have to do it. I have a good friend of mine that says you do not need a driver's license to drive. You only need a driver's license if you get caught, right? So yes, you can get away without using an absence of voltage tester until someone gets hurt. And then the company will be fined because you did not have proper training and work instructions according to OSHA. So you only need to address and use these devices if someone gets hurt. If no one gets hurt, you can keep doing what you're doing, but if you want to err to the caution of safety, then you have to use safety rated devices. And if you look at it as well, using an absence of voltage tester will decrease the time to verify the absence of voltage by at least 10-20 minutes per test. So you'll save time as well.
Thank you, Sergio, for the answers. And I do not see any further questions. So thank you everyone for your time today. And the recordings for this session will be provided along with the presentation in the PDF format. Thank you.